events available. Why you need all the events?
Because every event is important there, it is a real time network.
Every event is important. And what we do with these all events? It's the behavior of the system. Total behavior of the system I am able to understand by recording all the data. If I am able to record the data of various activities, that means I know what has happened historically. If I know what has happened historically, what caused the effect, what are the relations between all that, so what is really happened, that I will be able to understand. That's how we made the entire railway signaling system. So every relay, what has happened, which relay first operated, which relay next operated, which at that moment what is the voltage, what is caused, and what really affected, the entire history is there. Once I have entire history, the root cause of the problem can be identified. If you identify the root cause of the problem is by what? Is it a human error? Is it system failure? Or that is only failure at that point? Or it's failing continuously? So all this information when you have, then after analyzing all that information, we can go and correct the system. So the first thing when we put the data loggers in the railways is a signal crossing danger. It also when we put the first system, the drivers are left and right crossing the red signal. Like what we cross here. Immediately some officers started giving a memo. Next day strike. This system has to be removed. But railway officers said, nothing doing. You are doing mistake. This is going to cause accidents. So afterwards, that was expanded in a multi-dimensional across the country. Because initially we made only single data logger, single computer. But afterwards, it networked for an entire division. All the data from a division headquarters, the division, every station information comes to the division headquarters. By sitting in a division, one can understand what is happening. That's the first stage. The second stage is, after seeing some of the patterns, we started giving alerts. At so and so time, so and so signal point, driver crossed the red signal. That's a simple logic. So these type of simple logic started giving multiple opportunities to solve the lot of problems of the railways. Up to 2-3 years back, almost we brought down to the zero accident. Accident almost zero. Again, recent 1.5 years back or 1 year back, this Orissa accident is the biggest accident. In that biggest accident also, there is 3 root causes, not single root cause. Multiple mirrors, mistakes. Maybe we don't know, nobody knows. More than a year back or 2-3 years back, some of the spare contact wire is shifted for the live wire. Some wire is not working, that's labeled with some numbers. That was shifted to the spare wire, but the labels were not changed. It looks very silly, but that is the root cause of the accident. That's working fine from last maybe 2-3 years. Suddenly, what has happened from morning to evening, there is one mission called a point mission, which is meant for diverting the train to loop line to the main line, or that point mission is failing. When it is failing, unfortunately in India we don't have much time for a repair. Because our Indian Railways works 125% of the load. They don't have time to stop. Because of that they can't repair that. Because they are not able to repair it, from morning to evening, station master gives a signal, operation. Some maintainer will manually rotate that, and then give signal to him through the wire, it is walking. Then the moment he gets that signal to his system, automatically when he apply the signal will work. That is happening from morning to evening. Simultaneously, some new equipment is added there. The new equipment, what they added, they thought that spare wire is spare, which already they started connecting. This is the one which is giving a feedback to the station master. Because the moment that new equipment is added, this fellow given an operational signal, and before he operated, that gave a signal through that new equipment, and he got a signal. Instead of going the train into the main line, it gone into the loop line. Because of that.
When single level, the system would have got it done.
Yes, minimum 2, 3. That's where the deterministic technology works. So this is all about the events. That's
Okay, 2 minutes break this. Tea finish this.
okay.
Anybody needs to take a restroom break? 2 minutes. Ramakrishna garu, what did you study? Which branch?
Electrical engineering.
Okay.
Then the doubt వచ్చింది.
Mechanical and good note chest.
And of course I did 5 years engineering.
Okay.
In the 5 years engineering I studied civil, mechanical, because everything is there. In mechanical even we used to operate even lathe, even milling machine also. Start from molding, because 2 years is common for all the people.
Yeah, we also did that. Only thing is, work, the shop floor people, they would do it for us while we watched. And so we finished.
Basic workshop,
Yeah.
first year, 1-1.
Yeah, so.
And welding will be.
No, but I just wanted to
Welding and
mention that because, civil engineering, electrical, electronics, they're all there. Even though he is from electrical, he knows a lot about electronics and civil and mechanical. So, well-rounded, having well-rounded knowledge is something that you need to look at to be a true engineer, which I'm no longer. So.
It's like now a new term has been coined for that, like you should be systems engineer basically, rather than.
He had a conference on the 23rd.
Yeah, we only have systems engineers. Okay, we need people who can do things also.
Yeah, but like systems engineer.
Basically what is happens is that system, without system engineer, people are thinking silos.
Silos.
No, I'm a systems guy, so I need people who can do the silos.
No,
I'm not saying okay.
No, I need people who can do silos well. Otherwise, I don't have people who can do things.
No, the thing is silos and systems should be there more, right?
Yeah. No, I'm just joking. Like,
Yeah.
see, the thing is, until unless you're competent at something,
Yeah.
you can't go beyond. Otherwise, half everywhere, nothing will get.
So this is for any IoT, this is base. Of course, when I want to transport this event, I can have 2 bytes of header, 1 or 2 bytes of footer, saying that this is a packet. Because in this, everything is variable, 0 to F. All possible combinations is there. The footers, AA55 or something, or the bracket, or whatever you put it, that indicates, okay, the packet started. Even one, you start middle also, at least it will identify the next packet. Correct. Okay, that's what I started talking, current challenges of stacks. Most stacks are built outside the India. That's where we'll be dependency on foreign vendors, license, high cost, and then control issues, lack of customization. If I want, they can't customize it. Always, you have to follow whatever
Industry
they
trends.
say. Pitfalls of using of the set already available stacks. Generic implementation, not optimized for specific applications. Huge things are there. If you are going through that path, hundreds and hundreds of the various combinations, permutations. Again, high latency, unnecessary processing. Majority of them comes with the AT commands.
Yeah.
AT commands is that always will start with AT and then this all ASCII communication. With all ASCII communication, it is a high, your understanding of that AT command itself needs lot of performance issues in the things which is communicated. Huge impact is going to be there. Technical challenges, high overhead and the bulky architecture, increased the complexity, increased failures. This is what we saw. Multiple layers of translations, abstractions, multiple, all that layers has to be there. So that makes use of legacy AT commands. Impact of throughput, latency. End of the day, that is more important. So if you want to communicate, when you are talking, you want to communicate, the latency is more important. The moment I want to take action, the others should respond. If it is taking more time to translate, send that information, naturally you can't control it. Because by the time you want to take, the cycle time of the control is going to be high. If it is cycle time, you have a lot of other challenges. So the this throughput and latency is a critical aspects which we observe in most of our building the systems. That's extra translations, that is what we are discussing. And processing overhead. This side also you need to have high-end CPU to do that. Packet loss due to inefficient error handling. If your error handling is not done properly, packets are lost. So learning that stack itself is becoming hard. We think that is solving our problem, but reality, understanding stack itself is a bigger challenge. Not only understanding the thing, suppose today I am buying from one company, that fellow will come with some bugs. Understanding his bugs and solving it, suddenly that fellow clears that bugs and modifies something. Again modifying according to his dance.
Whenever a new patch comes in, we have to fine tune our code again actually.
Yeah, that becomes a bigger nuisance.
Yeah.
Because most of this IoT device, you can't think of changing the things so rapidly. And again, spares when you are sending it, again the spare will have different characteristics. This has a different characteristics. So multi challenges which we identified around that. We use it to use one of the SIMCOM chip, which is a GPRS module. We use it to do work for some of the US client, gate company. It's a really hell with that. So always some bugs used to be there that is not documented properly. In that document, that will, after some time, he will change something. And after some time again, when you ask, he say, you change the firmware. Okay, we fix everything. Next version will come with a different. So multi-dimensionally headache. If you would have made that type of things by ourselves, with the low cost we would have completed things much easier. Of course, working with these type of stacks also big challenge, because Qualcomm and all that people are very not openly giving the insights, especially GPRS models, but not for other things. All other things we can do it very easily. But the GPRS model still, when recently also last year when I talked in Embedded World with Qualcomm, he said, no, are you going to sell millions of things, then I will be able to do it, otherwise no. So this is one of the challenge with the GPRS models. I hope now things will change, but still they are controlling that. But remaining all modules, there is no issues at all. When you are doing full control over protocol and implementation, that is our protocol. Now, previously when I showed the protocol, to implement that protocol, I had to do a lot of things around that. Now, if I know my protocol, I will send that protocol to directly to the middle layer, data layer or somewhere. Then the data will move very easily without much of the overheads. Optimization of specific use cases, that's what I want this to happen, this is a use case, I will build for that. It is going to be cost effective, no license issues. The cost is going to be at least multiple times it will reduce. Now what we are doing, we are buying a stack. That stack is coming on some PCB with the connectors that need certain specific power supply, and we need to, our CPU has again certain power supply. These two has to be
Different
interfaced,
speeds.
and again different PCB connections, bulky. Physically it's bulky. The second time is the cost is increasing not only by the electronics, by the connectors and the PCB and all. Apart that, his license cost, his modification cost, his understanding cost, all that. Now what is happening is this CPU plus that stack, whatever the things, is coming in a single chip. Even I need not interface the ARM processor or whatever. That is also available in the stack itself, SoC itself. That means single chip is doing everything. So the cost is at least the stack module cost and the chip cost 1/4. That is gives a totally different dimensions
Advantage.
when you are able to optimize for specific use cases. Cost effective, no license use. Security, no backdoor entries like what we are talking, Chinese entry or something. So lot of people will be ready to do it because modular and lightweight, it's going to be very simple. Only in the stack also, what are the things what we want only we'll put it, not all the bulky things we remove it. Avoid third party vulnerabilities. All that, whatever mistakes they are doing, we are not vulnerable for that. Whatever the things under our control. That makes, even recently when we made Ethernet connectivity, we removed multiple layers because what in TCP/IP, if I want to only send the data below 1400 bytes, I doesn't need to have multiple packets to be sent. It is only some 1400 odd, and like that you have to go on putting and serializing, and lot of activities has to be done in both sides. When we build that, I know my application doesn't need more than 1400. Even if needed also, I am going to augment it. So I had to remove lot of other layers in that. Thereby, my stack is become
Small.
and simple. Not only small, it has become a very simple to operate and simple to develop, simple to identify. Any system, when I will go to in that, any system when you are building, you go with FME, failure mode effective analysis. When you are making a complex system and making a failure mode effective analysis, it is going to be very big work. If it is a simple system, if you are doing FMEA, very few dimensions only is going to see. That's where one has to see how simple our system is. That's where system engineering activities will come in picture. How I can make system as simple as possible based on the functional requirements. And it is going to impact on reliability and maintainability because you doesn't need to, because the modules, if the fellow is changing his module and this says no longer I am going to supply. Today, Government of India is talking semiconductors soft. You want to make it nice, but the challenge is I have a very bitter experience. China people made one IC some 10 years back, and it has a few better features than other one, and it's costless. Then I attempted to use it and started building application. It has multiple bugs. So somehow I managed all that, build the system. After that, what is happened is, after 3 years, that is, company is closed because nobody is buying. Because any semiconductor module, semiconductor cost is only hardly, in my opinion, around 10 to 15%. Semiconductor cost is only that. It is remaining development cost and connectors and housing, all that will cost holistic dimensions. But for the 10%, if you are only trying to save 5% or 10%, it kills the thing. That's where the biggest challenge, which nobody is anticipating. And today what is happens is, internationally, only 10 to 20 leaders is there. We tend to go only to them because they know the entire challenges and they have trusted scenario. Whether it's a Texas Instrument,
Longevity.
15 years, 20 years.
Yeah, that's how the Texas Instruments and analog devices survive.
Yeah.
Because they are so consistent.
Even when we are choosing for a system, we ask them how much is the longevity.
Freescale gives the longevity and the.
Of course, every company now, unless they are not going to do, you can't use that in our design. Sometimes what happens is, we started using a outdated chip, and within 2-3 years that becomes a obsolescence. Then after 3-4 years, that shall say no more
End of
supplies.
life. End of life, no supply.
I am using 68K mic processor from almost last 25 years in same design for the data log. Only recently we changed. Almost 7-8 years back they said no more. Still there somehow that particular chip is available in the market because lot of systems built in around that. Maybe not directly or indirectly, somehow still we are recently only, last 2 years back, we started heavily for coming 3-4 years. So these are some of the issues. Seamlessly upgrade and even that type of things happens also. We can manipulate because we are building a stack. I can modify the chip, whatever the PCB and adapt the new chip and change the things whatever is needed very easily. If it is the other party, it is very tough to do it. Independent development cycle. That's all. We need not bother about what he is doing and all that. It is our independent development cycle. Maintainability is easy because that makes that. Now come to the simple dimension, where to get all this knowledge. Okay, I talked a lot of things. Now, the great thing is there is a lot of alliances is there. All the semiconductor manufacturers of the technology has members of that alliance. So if you go to that alliance, suppose the Ethernet alliance, that means whoever wants to know about the entire standards, everything, if somebody goes into that Ethernet alliance, you can get this video, whatever the things, they will give the copy. It's not nothing to it. You need not write it. Similarly, 3GPP or otherwise Wi-Fi organization. This is a Wi-Fi alliance. Like that, everything has a different alliances. CSA IoT organization has its alliance. So you get a lot of knowledge and standards from that, which makes us to not do the same mistakes. Many times what happens is, initial stages, I try to learn by our own because of the data is not available. Getting a Motorola 68K chip details, I had to stay 2 days in Chennai, and Motorola company representative, one person is there. I have to make him to understand that I am genuine, and he has only 2 books. Somehow he gave 1 book for 1 day to take Xerox.
So, I mean, it's interesting you say this because this is not the case. So, I have family who've been in the US since like when semiconductors came out, right? So, when they tell their stories, for them getting access to the manuals, getting access to the technical specifications was a lot easier. So, we are also dealing with a lot of people problem over here in terms of like not actually communicating, not actually telling what is necessary. Like, mere genuine kaakpote, what difference does it make if you are able to look at the spec? Because if you are a potential customer of his product, you need to know how it works, no? So I don't understand. Like, I think a big chunk of it needs to be being open to conversing with people, telling what problems are there, or sharing information, because your business only grows when you work with other people.
That's true. Of course, generally that is where the, our Indian.
No, that's why you're here talking about this because you believe in that, but that I don't see everywhere else, which is very surprising.
Of course, I agree with you. Basically, not only somebody is saying, even my relatives and my uncles and all used to say, keep everything secret, don't tell to
Yeah.
everybody. But I don't, in our organization, our philosophy is from the starting, all the documents is open. Whoever even intern come to our organization is, they can access to all our design documents or whatever the documents. Even many times this particular protocol, one point of time in 2004, railways asked, because the competitors are not able to do it, we want to shift it to CPIP. Then I said, TCP/IP is a very big protocol, it cannot be used in this way, because you want to send it on a modems. Practically it's impossible to do it. Then I said, I will give the protocol to you, you publish it as a your own standard protocol. Then that was given as a SP06 protocol of Indian Railways. Now all the competitors is making a same protocol. Not only that, now because of that, what has happened, good thing for India is, even international companies which comes to put their system here, they have to follow this protocol. Now,
That's what they have to do, so Europeans do that, so we should do in India also.
No, I mean, that's the main thing, right? So when I graduated from EC, my undergrad is in EC. So when I graduated, I kind of thought about it, you know, why I was working in a company where I was developing a full stack also. So the question was, you know, I was like, okay, Andhra generates at least at that time 1 lakh EC engineers every year. I mean, seriously, like we were generating 1 lakh engineers every year, which means that in terms of sheer number of people who are coming in, we should be setting up all the standards for every possible means of communication. So it's a people problem is the first problem, is my opinion. In general.
It's part of the evolution.
no,
Yeah.
I was there are
No,
three things.
no,
No, that one is the cultural dimension, basically. No, the good thing what happened to me when I was in IIT Madras. Before that, I studied BTech in NIT Surat. When I was the moment I joined in engineering, I used to feel, no, I am an engineer, so I should not use a bicycle, I should not use this, lot of things were there. Then the moment I joined in IIT Madras, our director used to one day walk, and second day on bicycle, third day on scooter, fourth day on car. If you want, he have access to the car 24/7. But the moment I saw, immediately I gone and purchased my bicycle. So that is where the culture, even professors, they used to ask sometimes, no, did you understood anywhere in your learning this particular contest of this particular challenge? They openly used to ask. They are all again double doctorates and good. After all, we are just MTech guys studying. They don't feel that we are great. So these type of things changed our what is called mental mindset. So the mindset also, one thing has to come from institutions where one has to improve the mindset. That's something which I feel is missing many times. That's maybe one of the directions.
No, I mean, I 100% agree. Like, I spent the last 10 years not in India, so.
Yeah. Even another dimension is that I go to the international trade fairs every year, 2-3 big trade fairs, and not just I go on few spots. I scan entire thing, whatever is there. Something is not relate to my business, not to relate my business because of curiosity.
Yeah.
When I am scanning, the biggest great thing I used to see from especially Europeans is they ask, what for you want this product? When I say this is the product I want, this is my application, sometimes they used to say, this product will not work for you, go to that stall and take that product that is useful to you. They are so genuine. But whereas if I go to the same thing, any trade fair in India, even he knows that 100% it doesn't work. Still he says, no, it has everything. This is the biggest challenge which we see with the Indian mentality. I don't know how this all be built, whatever it may be, they don't trust. So these are the various alliances which you can look for all these technologies. Still there are multiple alliances available, and where you can find not only the technological stacks and how the standards were there, and who are the people supplies this, and all that information you will get in a single spots. So even if I believe all the colleges should have a clubs
Yes.
of these alliances, then the knowledge will spread. At least couple of professors should be master in that areas. So that makes whatever the knowledge pool comes to the our institutions. And like that, many things are there basically. Now, this is another Ethernet Alliance roadmap. How the roadmap is going to be on, how this particular Ethernet Alliance will talk majority of the aspects of it. So, previously I talked about some of the things like EtherCAT. This is able to synchronize the activity between this system to the other system in a microsecond level. Microsecond level, the systems is synchronized. Suppose you are making 3D printing or what you are talking, something, this has to happen, same time this has to happen. If both are going to synchronize with a microsecond level, then the correctness and the predictability comes very effectively. Suppose this is working one time, this is working another time, that makes again that particular protocol, EtherCAT is a very simple protocol, works on Ethernet protocol. So what is that in any of the stacks? This is what we are talking, physical layer, where the connectivity of the electrical connectivity all happens. Then framing, that is a network framing, what is the data header, and then the entire information is in between. And then every layer will be going into the deep into the bottom. So this is what any communication stacks will work. This is where the Ethernet we have a application layers, different, even our what is called mail.
Yeah.
SMTP. Everything will come into these application layers, or browser, HTTP, or file transfers, and all that. These are all various application layers. These are all sips into this Ethernet. Suppose you want to control all these ACs and lights and all. Majority of the now startups will be talking about
Home
automations. It need not be only home automation. Any automation in factory, or even like recently we are working, giving some technical support to some of the aqua application. So previously the people started building aqua from last 10 years. Some people have gone to the investment and made good money also. But still they are not reliable. Now our technology, what we implemented in the railways, we started giving it to these people. With everything in a bare metal. That means bare metal in the sense, no third party applications, stacks. Everything is written on a base on the CPU level. Suppose somebody understand 80, 85 or something, start from the instruction by instruction. That's maybe we write in C, but there are now a lot of tools available like Keel and all other things, which will enable you to build the applications directly on the chip. Now the advantage of the chips is now there is a small chip of a ARM processor is available with maybe 2M by 3mm, and it costs 10-20 cents.
Chip scale package.
It's very small. So these are all what is the advantage. TI, it doesn't need crystal, it doesn't need lot of things.
Yeah.
That means a very, very small activity. So these are the knowledges which is a high paying jobs also for the students. Even in our company we have software people, analytics people, hardware people, mechanical people, everybody is there to build the systems. But if somebody works 2.5 years with us, the fellow who is a weak, minimum they are getting 8-9 lakhs. If he is a good, he is getting 15-20 lakhs back. Whereas software people, if they are good, they are not getting more than 10 lakhs. Unfortunately, software, okay, more opportunities are there, but reality, software don't have that much high salary, whatever the demand. But fortunately or unfortunately, hardware has more, but it's not easy to work. Because one has to understand how the chips works, because software people without knowing also they can do it. In the sense, copy it from a Google blocks and all, build the stacks or whatever it may be. If they don't get the answer, they get again put that same requirement in a block, somebody answers for you and do it somehow manage it. But there also the challenge of building a better software is there, but still in market, now the people who works on a firmware has a lot of market, in the sense. I don't know how much is there, but there still is there. Now what is that happened with these are ZigBee protocol. With ZigBee means what happens, multiple systems has to interconnect. If this system fails, it will find the shortest route to send the data, and they will all talk each other. End of the day, the data will be transferring from one place to another place, whatever the route you want, where the source and destination and all that. Now going into the deep into that, what is happening now? So you have a multi-protocol SoCs available for wireless. All that wireless stock is here. It only has to configure. And the remaining, you have a good amount of CPU. ARM CPU is available, then same as SoC. You need not put external CPU. So when I build this is going to be a small chip. It's doing a ZigBee application, and as well as your computing, and these two are closely connected on the bus. So there is no necessity to exchange the data with AT commands and all that. In between, all layers can be removed. Straight away, what I want to send it, I will send it through RF, and we'll be able to make it easily. Based on the application, you can change the application requirement also very easily, so that your stack is going to be very simple. Once it is simple, as I said previously, FMEA is going to be easy. That is where the failures are there. Identify the possible failures. FMEA applying is become much easier, so that it will be highly reliable. And this is what now we started working. Thereby, we are able to get the highly reliable systems, because all IoT systems has to work without people.
Yeah.
No, we can't expect somebody to restart like a computer, because in computer what happens if say software is not working, you reboot the things. But there is no chance to reboot, there is no chance to do that. So whatever we are supplying to the Indian Railways, the railway station is not accessible. Even if somebody has to change the things, we have to take permission from railway officers, and that fellow has to give he has to come along with our service engineer to do all that. If that has to do, one side their challenge, our challenge. And again, each call costs minimum 5,000 for us to go to the some remote. Though that fellow is very nearer, maybe 10 kilometers, 20 kilometers away, travel to that railway station and fixing a simple bug or otherwise change card costs 5,000 minimum. So that's where we have to invest more on development instead of spending all that in it. That's where highly reliable systems we have to build. So some of the systems will not be rebooted for 2-3 years. Still continuously working without maintenance. So these type of highly reliable systems, if you want to build, FMEA is a must. If I have to do with the FMEA with the external stacks, my work is going to be very high, because I have to understand his stack and I have to understand everything. Wherever the failure modes are coming, I have to understand the signature, what type of failures is coming, what type of activities is coming. So these, now again, these communications, now there are multiple alliances worldwide. One is a Bluetooth, this also can go into the mesh network.
Mesh network. Yes.
And then thread is another standard, and then matter is another standard, another is a ZigBee. So for all that, again you have SoC7. All are wireless. You can see all these companies, Silicon Lab, NXP, Texas Instruments has stack 7. This SoC7 in the market. Now today, as I said, 70% of world market with ARM.
Oh.
I believe,
Probably more.
Huh?
It's probably more.
maybe, that's what I have in ARM-based chips shipped today is 280 billion. 99% of smartphones run on ARM-based chips. But pathetic story is nowhere ARM syllabus is properly there. People say ARM, but again they talk all nonsense there.
Yeah.
And when I ask a lot of professors, they say for learning only 8085 is easy. So they want to put even 8085, which is chip is not available in the market. Almost from last 10 years, I am not seeing that chip in the market.
In different forms now. Neoton is one company which is providing it. That's it.
No, that's it.
Yeah.
Maybe putting some SOC around and doing it, but as it is, it's not.
Not available.
No, we started with a party plus years back. Still, we want to work with that because these SOCs in ARM process have everything. You have flash, you have RAM, you have peripherals, you have crystal, everything is there. A single chip, just give a power supply, you will not need to be sometimes regulated also. It can take a variance of the voltage and can be put a power pack of lithium ion battery and also can operate with that. And then consumes very, very low power. It works with high speed. Multi advantages were there, but unfortunately, again the costs are also here somewhere.
In the second.
Of course, these are peripherals for how many megahertz it works and how many flash, how much flash and how much RAM, how many AGCs and DACs and PWM timers and communication ports, how many are there. So everything is available in the same chip. So you need not struggle for it. Initially when we used to work with a 68K and all, connecting each peripheral is a nightmare. All timings we have to take it very carefully. If the timings are mismatching, that doesn't work. Even today also that challenge will be there if you are doing. But everything is inside, I need not worry about it. Easy to make it. I think you have to think something different.
It is taking multi-tester, right?
Huh?
Yeah.
Gone to the first.
Is it just a PDF viewer?
Huh?
Yeah, so, yeah.
Why don't you go ahead?
I'll just help you.
Still.
Yeah, just do quick.
No, just go through. Yeah. There are sub-dollar ARM. Sub-dollar means half dollar, 20 cents, 30 cents. So one can have multiple. Now that's where the car and all has multiple CPUs because they are all sub-dollar. So a lot of times previously for if I have to measure multiple analog voltages, I used to put a lot of analog A to D converters. Now we are just using a ARM processor to do that. Every A to D.
How many processors are there typically in like a Tesla or something like that?
We made one is a battery health monitoring.
Mhm.
Suppose I have 28 batteries, each battery has to monitor.
Yeah.
Each cell has one processor.
Mm.
Usually there are around 600 to 700 different
Yeah.
control units.
Yeah.
We were talking to an EV company. So
Yeah, but in general, that's what, when we were talking about, our laptops. In fact, most cars have more processing power than a laptop or a a CPU.
That's another advantage. I can localize the entire calculation, and only the conclusion I can send it, which is needed, all filtering or all that. In general, what is happens in any event generation, especially Alexa, when there is a change only, I will create the record event. If there is no, I will have some tolerance. If I want more accurately, 1% or even 0.15% or something like that. If the variation is more than that only, I create event. That all calculation is done in that small CPU, and that only sends the information to the master CPU. Like that, lot of communication activities will be, that calculation is done in various. Even today, what people are talking edge, that means what is if I have multiple changes, some voltage is operating, chartering basically, high voltage, within every cycle the voltage is going up and down and up and down. Then what I have to do, I can't take all that data and do anything, because there I will be calculating average, minimum, maximum, and few of the statistical information and sending it to the center so that I can understand what is the behavior of that type of scenarios. So like that, many of these things can be done in the tiny CPUs.
And also there is like sleep provision provided in the CPU, so that like it minimally consumes power basically.
But they are very tiny, very low consumed. So this system engineering approach is very much essential here because of my whatever my experience. Without that, the type of when the multiple systems are getting connected, when holistically if somebody is not looking into it and controlling it, this fellow will do some change, that fellow will do some change, and after the chaos is happening. So when we take system engineering approach, almost maybe 20 to 80% change will come. That's where system engineering approach is the one thing which we need to look into it for a reliable design. Majority of the times in India, what I observed is a lot of systems, POCs, they are able to show it nicely, but afterwards, 100% systems are failing, especially from startups and all, because the reason is they are not holistically looking into it. That is making a lot of failures in that, which I saw majority of our competitors' failures also because of that.
Thinking about systems engineering is not that simple.
Of course.
Because it's very difficult for especially young engineers to have that, because they are just coming fresh out of college and they may have only some knowledge in only their domain, and for them to kind of think through in a broader sense is a little difficult. So like you said, we need to change the syllabus, we need to change how 4 years of engineering will help them at least get exposed to some product development, some systems thinking, even simple things that will expose them to that kind of systems thinking. So when they come out, they can use that methodology on new products.
But that's where I am struggling.
Yeah.
First 1 year, 2 years, it's very tough for me to convince them. Because they want to sit in front of the computer and write the algorithm. Even if I ask them to put all in a documented with a structure and all, even not only in system engineering, even in software development life cycle also they doesn't want to follow. They want to write code directly. Then after some time, all bugs will come, and even when I force them to do it, what they are doing is document they will make it for me, but the implementation they do it separately. Even that also I have to get verified. That becomes a bigger challenge. If these dimensions were taught from the college level and make them to at least aware of these challenges, these problems can reduce and they can appreciate somewhat because of the various case studies or whatever.
It's like they have to get habituated to it basically before they go into job.
No, at least in STPA, I evaluated in the startup areas. Many of them are just routine.
Yeah.
E-commerce or either. No, no, they didn't even look into the holistic dimensions. All gut feels. And actually, even some of the people who implemented, not now even from last 10, 15 years, they not only lost the money, the entire family went into the debt. Father who earned money, the hard earned money up to 3 crores, that is gone, and they have 2-3 crores extra debt, and they are on the roads. They are not able to show the faces. These are the hard realities.
I mean, there's a harsher reality underneath this. I think part of what you're talking about, we've had like a lot of interns come in, a lot of student interns and stuff. And some of the things which we've been observing in terms of like the students themselves who are coming in as interns, and it's actually easy to spot now because people use ChatGPT for writing software. I also use AI for generating some of my things because I'm too lazy to write loops.
Yeah.
But the problem is when they don't think about what is the problem solving method, use it as a tool to help bridge the gap, right? Like I work in like at least 6-7 languages, so I don't remember anything anymore. So I have to keep switching and I use it as a crutch. But the point being is they are not actually spending time thinking about what it's generating or are in a position to evaluate what the output is. So you don't use it as a way to like as a sounding board to get more ideas or to just get rid of the mundane. They're using it to solve problems which they don't even want to think about solving. So, but I think this aspect is we are only observing this now, which has been there for a very long time.
Yeah.
Because of the tool. Before that, what would happen? They would not even attempt to solve the problem. So the fundamental difference in the education system that we are talking about is not about updating syllabuses, all that I think is valid. But that is not the core problem. Core problem is people, why are they doing engineering? Like, amma cheppindi, nana cheppindi, babe cheppadu, is okay. You do it for money also is fine. But when you do something, do people have the drive to be competent at doing it? Again, it's all about how we are building our ecosystem, what we're doing. So, which is why even Junaid and I, when we do stuff, we try to sidestep all this. We try to say, make reason, come up with whatever reason you want, but do the work. So, we try to make interventions which are targeted towards changing the thinking pattern more than tangible skills. That will come automatically. So, sorry for the monologue here, but I think, we've been talking about this for a while, and I see that you're very passionate about it, but I think we've been going about this the wrong way. We try to keep updating the syllabuses, try to make all the different levers over here, when the real people who need change.
What I mean is changing the syllabus is not just bringing all new.
Yeah, exactly.
No, basically, a few days back, I have a discussion with all senior faculty of one college, starting from principal, HODs of all. They were want to improve the thing. Principal is not able to convince the HOD of the computer science. The computer science HOD thinks that everything trial and error only we can teach the computer science. Then I started questioning it. We have a structured way of learning. If you are not structurally learning, what is that happening? You are getting somebody getting a 30 lakhs package in Amazon or something. Oh, is it that he is learning structurally or brutal force? The majority of them, they are using a brutal force. When they are using a brutal force and join in Amazon, how many years they can apply the brutal force? Only certain years. Afterwards, if they get this thing, all mental tensions, everything is going to start. After that, they have to leave the job. That's what is happening. So,
yeah, but
the fundamental.
In the correct Kani in the process of trying to convince HODs, principals and everything, the actual change which has to happen at the student level is not happening is my point.
That can be done. It's a proper methodology that can be done.
Yeah, and
but basically, in our training we did one thing, two things. We had to train on a sorting algorithm. how to start. Tell. You can do mathematically many things, but how they feel it. We gave a playing cards. Ask 10 people or 20 people to sit. Everybody is shuffled card. Ask them to put in some order. We started measuring how much time they took. First round is over. Somebody took 10 minutes, somebody took 3 minutes, somebody various times. The fellow who took more time, he has to stand and observe other people. Like that, 10 rounds is completed. After completion of 10 rounds, all the people come to very narrow band. After getting narrow band, we started asking how you did it, write it on a step-by-step process. When they do it in step-by-step process, they will be able to understand what is the algorithm, how to build the algorithm. Again, the entire this thing is put on a notice board, pin board, and ask them to evaluate which is better algorithm by themselves. So people are able to appreciate, and the people who are weak also, they are able to identify their intrinsic talent, and they started performing well. So there are methods has to be identified. That's it. My strong belief is, again, the lot of teacher role is there, whether we are paying enough or are we able to bring a right talent into the teaching community. All that is the challenges are there. That is I agree. But still the teacher and the curriculum has to be, teaching learning process has to be improved. Then only the things will move in a larger scale, in a better way. That's what my strong belief.
No, I mean, I agree with you. The question is, like, again, I talk about like whether it's within my batting range. I can't convince principals and HODs to change the way they think. So my entire strategy is don't even look at them anymore. Go
Of course,
somewhere.
basically two things happening. Up till now, Infosys TCS is taking a 3,300 to 400 people from college. Now that is stopped, reduced it. When that scenario comes, everything will slowly come.
Automatically change.
That's where now the people are listening. Otherwise, people never used to listen. So this is in my opinion, most important. So that gives a holistic system design approach, optimization of the performance and power, and then modular architecture for flexibility. All that can be achieved through system design. Designing lightweight, high-performance stacks. Memory footprints is going to be optimized, and minimizing package and processing overheads can be removed. So that makes a
Actually, these days nobody is thinking about memory footprints.
but still
They're
certain areas-
increasing the density, they're
no,
increasing
still
the-
at certain point.
I
Basically-
believe that should be done. Yeah.
But now we are all talking AI. We are now talking about a smart meters of large number. Entire country need to be smart meters. The pathetic scenario is they want smart meters, but how they want to communicate they didn't finalize. And then how to use the data they didn't finalize. In some meetings we are telling first you complete up to the transformer level, which is easy to do it. Transformer input, output, and I can optimize entire up to the transformer level, which I can predict many things with that. Load balancing, many advantages will come up to that. No, I don't know, somebody said, you make smart meters, do it. Again, what is the value comes from our, what is our current bill? Our house, what is the current bill? In my house, the average current bill, minimum start with a 4-bedroom, 3,500 to maximum goes to 10,000. If it is a 1-bedroom or 2-bedroom house, how much is going to be there? So hardly 1,000, 2,000 power bill, and you are putting a smart meter cost 4,000 rupees or something. What you want to achieve through that? Meaningless implementation. So this is there. Some of the policy makers doesn't understand the optimum way of looking into the system and value dimension. The first point which I brought is the value. Whatever you do, end of the day, what is the value we are building? National level and state level, one has to think on the value dimension. Everyone has to think. All of us see the value only. When you go to the shop, we look for value only. We are not generous to buy whatever is made somebody. We are all, any small item also we look for value. That is the first point every individual has to understand, all policy makers has to understand. That has to come into our curriculum also. When it is a lightweight, you can apply the FMA very easily, and we can understand possibilities of failures, where failure is possible, what is it, all that we can apply. Identify potential failure mode and mitigating all failures, what if that failure comes, what has to be done and all. That makes the system relatively risky. Testing validation of stacks, throughput and latency, and error rate measurements. These are the few of the issues which is needed. Continuous monitoring and bug fixing. Periodic updation, security patches. This is generally what we have to do it. But in this, even what we did, some of the things is that when we are generating a huge amount of data, what is the latencies is coming? This spike somewhere the problem. Then suddenly the spike came. That means the data is not moving quickly at this point. This is a lag. How much lag this data which is created is reaching to the end destination.
This is from Wireshark?
Huh?
Wireshark?
No, this is Power BI.
No, Power BI.
No, all our equipment, when it is as I show the protocol, then the timestamp is there in the sourcing point. Receiving point also I add timestamp. Then the lag comes into the calculation. That lag, I use it in push this data into the Power BI. This is a lag. This is a number of packets created. Red is the number of packets received. And for every second we measure that. And
right, like MD5 hashing and stuff people do to check whether the data is as it is when sent from one side to other side, right? So what kind of protocol you are using there? Like you have your own protocol available, which makes it is unique that like somebody sniffs into it also, he will not be able to understand.
yeah.
So how are you securing it actually?
No, then I suppose that all bytes, if somebody doesn't understand what is the meaning of each byte and how that is configured,
Yeah.
he can't understand anything.
Yeah.
Even if sometimes in IoT, what they will do with this data,
No.
that's where some other things which I never understand. In an entire world, one two dimensions world is moving very high. One is AI ML, second is security. Where you need security? Just me put the point clear. Why I take snap some data, or why I enter into some system? If I have some financial benefit, I will do it. Or otherwise, if I am something sadistic mentality, I want to create a problem to somebody. These are the two dimensions.
Two dimensions.
Two dimensions. First dimension, majority activity will happen. Where this IoT data, what they will do with this data? Suppose that they capture all the data. What the financial benefit they get? Nothing. Because this is only monitoring. I am not controlling the time.
Yeah, yeah.
So what they will do? Who is going to invest on that?
Nobody.
If nobody is going to invest to sabotage, then why should I think about it? Again, when I want to go for a security, I have to add lot things in
Yeah.
every stage. Again, there is no limitation for security.
Yeah.
Where you want to secure? Which stage you want to secure?
Yeah, but what about security, sabotage is a major thing, right?
Yeah, sabotage also, if there is control, they can
Mm.
sabotage. If I am controlling the railway train, then one has to be with care.
Or they can use, some of the data to predict, when the next train comes or when, so that they can do some sabotage.
That can be done even outside also very easily. All the data is available.
No,
All the
that's
data is
true.
available.
No, I'm just trying to understand.
From last 25 years, we don't have single incident.
Mm.
Somebody even tried, forget about achieved. Even the things which we put in that protocol has a CRC and then sequence, and in between we have a hour packet. Hour packet is every 34 minutes, all input information is sent. This
Yeah.
and that has to match. If that is not getting matched, you will identify there is some error. So in that way, we will be able to identify where the problem is.
Yeah.
If somebody want to corrupt the data, because sometimes what happens is somebody wants us to corrupt the data if some accident is happened. But we say it cannot be corrupted just like that. If I change here, some other way, the problem will come with the data. So
No, because I'm just trying to
I
understand
have
the
some
science.
experience in encryption, the virus software. Apparently, there is one guy in Israel or somewhere. His computer has all the known virus in the world, and he buys the virus, new virus that they create in China. And for certification, everybody goes to him, and he is the only guy that authenticates and says your software is in foolproof, your antivirus software. So it also seems like a business where basically either you create the notion of sabotage. Probably I'm giving a different dimension to thinking, but yeah, that's how some of the software companies are running.
In somewhere 1988, we identified virus in our company. We shut down entire operation for 3 days. We have a capability to understand software and hardware. So at that moment it's only DOS machines. So we debugged everything and how this virus is getting transmitted from one to another, how to prevent it. Within 3 days we broke the entire thing and we created the rules. This can do this. And we put a press meet and put it, Hindu published in entire country. That's the simplest way to do it. Afterwards, antivirus started. As you rightly said, somebody creates a virus and then they create antivirus. That become a business. Now, everywhere everybody is talking security,
No, because I actually like trying to understand the space of OT, like operation technology security kind of a thing. Just now, the Siemens and like ABB, these machines, they have their PLCs coming into the picture. So they are in a position to control big facilities basically. So
because there is enough security things are there. Again, is it I am talking inside the system, outside the system. If I am going outside the system, then somebody can sabotage. Even take railways, which I know deep. If somebody, what is the way the sabotage action happens? There is an interlocking system is there. Interlocking is, what happens is, if I want to send the train in this, no conflicting train should move into that direction. That's where they lock all possible combinations. That's called interlocking. Only if it is reserved for this, other reservations cannot be taken. These are all inside the system that cannot be modified by outside. I can only give input to the system. You take the train in this line, or in this line, or in this line, that is out of the system. Suppose if I say the train has to move in this line, instead of that I can say the train should move into the other line. But that cannot be sabotaged because the moment there is another train in that line, this train will not be allowed by the system at all. So that is inside the system, enough security is there because it is not allowing other commands to come into it. The security is inside.
Yeah.
So this is what I am talking about, the data availability, whether my data is 100% available, where it is not available. This all with the Power BI, we are able to monitor that, and the serial numbers, all that is coming. And so they are all important aspects when we are communicating the data. I come to almost last slide. So when you are building, prioritize failure mode effective analysis. FMA is very important. Without that, if I am going to build a stacks, open mode, and only functional dimension if you take, even not only this, any system, in my opinion, FMEA up to certain level has to be there. Majority of the projects is failing in India is because they are not even thinking towards the FMEA. How
How
depth
many
you-
students, even, 4-year degree, how many people even know what FMEA is?
Nobody. Nah, forget about professors doesn't. Optimize stack architecture, performance and reliability. Leverage hardware acceleration, SoC integration. Then that's the easiest way to do it. That's a very cost effective. And when we are able to build it, we will be able to build it in a very, very low cost. And you can sell because the value into the total cost management comes down. Naturally, the value goes up. Develop indigenous modular and scalable stacks. Build for security and resilience. Collaborate, standardize for future growth. If you are able to do it, there is a huge opportunity.
So me and Krishna have like a debate on this thing. Like let's say if you want to pick up a stack to build, actually, like what would be the funding mechanism? Like how we could be able to pull people to work on a specific thing. Actually, let's say now for India specific thing. Let's say.
Yeah, I will give a simple example. We have struggling around Zigbee from a long time. Because all our communication around the railway stations is one of the area is Zigbee which we use. We are struggling with stacks.
Because of RE and that, because of RE.
RE is one dimension,
Yeah.
and still the stacks is not really doing well.
Friendly.
Okay.
A lot of challenges with the 80 commits,
Yeah.
this, too many challenges.
Sure.
In the best of stacks, we started buying across the world. Finally, one day when these SOCs came, we want to build the system around it.
Don't know what to write.
One girl who is doing MTech in a local college, she joined as an intern. We gave the work to her. Top side, we are guiding her. Within 6 months, she understood entire of the how Zigbee works and everything. Within 6 months, she almost required stack for us is built by her. So if some girl with a little focus is there, again she didn't have any background of RF, she didn't have any background of armed processor.
True.
So she is able to do it.
So we are not worried about the technical challenge of it. I think for us it's the problem market fitting is where the challenge is coming. Because you have been in the industry for 40 years, so you know what is happening. You know opportunities, you see things happening everywhere. While new startups who come up, see, you have the extreme ends of everything. As you said, a lot of people will show POC, nothing will work after that. So the engineering problems are there. But then the other aspect of this, which is really not working out for startups, is that, or at least young organizations, is because one, I'm not taking VC funding, which means that I don't have the liberty to hire like 10-15 engineers and get things going. I cannot jump onto anything until unless I identify a market need. So I can say, even if I take a loan and put in, I know there is some return on investment. So I have to play it safe.
Yeah, sure.
So, but only few people like you are talking about challenges which are there, needs which their companies might have, and that is not communicated properly.
Okay.
So, AHUB does a great job of doing these hackathons every now and then. But the problem is, again, it's in hackathon format. See, it might not be a good month for me to work on it. Again, it's a point of, can we go iterate? If it's a government which is giving the thing, I have to wait until they pass the GAO and give me the money. So this non-determinism in getting into the problem, solve it. It's completely fine if nobody pays me money. See my work. If you don't like it, don't pay. That is the thing. If you like the outcomes that are coming out of it, then we are happy to continue. I think that ecosystem where people are candidly talking about what is it that they need, what is the kind of stacks they're looking for, is lacking, which is why I think your talk was really good. But I think the bridge from there, it's not, at least for us, it's not a problem of doing. Like, we'll figure it out. If there's some things we don't know, we'll figure it out. Things which we know, we'll implement. Where we need help, we'll ask. There's no harm in that. But the bigger problem is identifying the market needs, and because everything is a closed circle. For example, we've been trying to talk to this one defense company who's working over there. Now they don't want to talk to anybody about what problems they have, because they're like, oh, in the future also we want to only capture this problem. Fine, it's okay. Their strategy, their issue, their thing. 100% okay for us. But when large organizations are there, they mostly tell me, oh, we will do it ourselves. I'm like, okay, fine, do it yourself. We might do it cheaper, better, you don't know. So that is the challenge. So I guess I say some things of culture because it's a matter of
course,
how do we
whatever
expose it?
your point is well, and I also agree up to certain extent. But same time, what is happening is there is a change happening because of certain dimensions.
No, 100% okay.
Yeah, because-
So mark entante, we just want to identify where the requirements
which
are.
problem or like which requirement is there, so that we can get like human capital which we have on campus to be able to sit and work on one specific idea. Let's say.
So that's what I told you. Go to the certain alliances.
Yeah.
When you go into the alliances, you will start understanding what are the standards. It's not very difficult to learn that. It doesn't need a huge investments. If you are able to identify 3-4 good, what is called talented people who has passion to learn, if you are able to identify a couple of people from a tech or whatever, but you people are going to guide them to look into it. So if necessary, you people has to get whatever the good thing what is happening nowadays with semiconductor technology people also, they are also supporting, unlike others. Now if I ask certain design validation, I design this, could you validate? They are doing it. No, even nowadays, even this stack also which we are building on a Zigbee, we sent to the ST. They reviewed that. You did mistake here, you changed it here. That they are helping. There is something like eval boards are available. With the help of eval boards, we can understand the functionality. You can at least some design you can copy it. Recently, we did one work for a railway requirements to the one of the well directly I can say. They want fail-safe system to be built for coverage. This is not going to be public still.
No.
It's only out close to
I mean, it's getting recorded,
We
so
can
maybe
stop
not.
it. No, we can stop it actually.
Yeah, no one will stop it.
Yeah.
Do I end the session?
Yeah.